Welcome back to Calculus 1. In this lecture, we're going to introduce the derivatives for the 6 trigonometric functions. All right, now we just said very briefly, hopefully you recall from your pre-calc course, that there are in total 6 trigonometric functions. What I want you to do right now is just focus on 2 of them, sine of x and cosine of x, and we're just going to pose a rather simple question. What are the derivatives of sine of x and cosine of x? All right, now we haven't talked about this yet in the course, but now we start to have some tools available, and we'll be able to get to all 6 trigonometric functions and their derivatives. All right, now before we get into this lecture, I want to make sure you are aware that for calculus and beyond, basically starting in our course right now, almost all of the results that we'll be getting to pertaining to the 6 trig functions and their derivatives, they are only valid if the angles are measured in radians. So hopefully you recall from your pre-calculus course, there's 2 units for angles. We can measure them either in degrees or radians. For calculus and beyond, we're going to stick to using almost exclusively angles measured in radians. So when we see, for instance, a function down here, let's say f of x equals sine of x, recall trig functions, we plug angles in. So here, your input variable x is an angle, and we're going to assume that the units for the angles are radians, unless specified otherwise, which I can't think of any time where we would specify using degrees. So when we see sine of x, we're going to interpret x to be an angle in radians. So just keep that in mind. All the results we'll be getting to within this lecture are only valid in radians. All right, with that out of the way, let's get to a brief review. So there's in total 6 trigonometric functions: sine, cosine, tangent, and then cosecant, secant, and cotangent. And what we're going to see very shortly is each of these functions has a derivative. So there's going to be 6 more derivative formulas to memorize. Now this starts to sound like a lot, but there's a reason why I want you to focus on the derivatives of sine of x and cosine of x above. There's 6 trig functions in total, but how many are there really? Well, I'm going to argue that there's really 2. So there's 2 fundamental or basic trig functions, sine of x and cosine of x. The other 4 trig functions are combinations of sine and cosine. So hopefully you recall some identities. Think of an identity for tangent in terms of sine and cosine. And some of them might look familiar. By name, these would have been the quotient and reciprocal identities. So tangent is sine divided by cosine. Cotangent, cosine divided by sine. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. All right, now make sure you're comfortable with these. We'll be using them a lot, but we're going to focus on 2 functions and their derivatives. Our main question, which we're going to answer first: what are the derivatives of sine of x and cosine of x? Now, let's relate that to what we're emphasizing, that there's really 2 fundamental trig functions. Once we know the derivatives of sine and cosine, we can just apply the quotient rule to find the derivatives of the other 4. Notice here, before we advance, the other 4 trig functions, tangent, cotangent, cosecant, and secant, they are quotients, fractions involving sine and cosine. So once we learn the derivatives of sine of x and cosine of x, we just combine them with the quotient rule, and we get the other 4 trig functions derivatives for minimal effort. Let's go ahead and get to the first function that we're going to find its derivative for. We're just going to start with sine of x as the function and ask, what is its derivative? All right, so we don't really have any tools available to us. Notice this is not a power of x. It's not an exponential function. It's a trig function. Now, what we are going to rely on is very briefly going back to the limit definition. Now, we're not actually going to carry this out since the simplifications are a little tricky, especially if you're not familiar with trigonometric identities, but I'll at least give you the rough outline of how we would work through this. Okay, so we're going to use f of x as sine of x, and then it's straightforward to apply the limit definition, plug x plus h into sine to get sine of x plus h, and then minus f of x minus sine of x. All right, now as it turns out, there's really no obvious way to simplify sine of x plus h. Well, let's keep in mind here, our input quantities to the trig functions are angles, and they are angles measured in radians. So x will be an angle in radians, h will be an angle in radians, x plus h is what we would call a sum of angles. Now what I'm trying to do is slowly give you a hint. If you recall from your pre-calculus course, at least by name, there's what are called the sum of angles formulas, each for sine and cosine. Now, I don't expect you to know these. There's going to be no requirement for our Calculus 1 course to know them, but it is used in the proof for the derivative of sine of x. Now, if you want, you can kind of rearrange that. It's stated below with angles alpha and beta. Just replace alpha with x, beta with h, and we get that expression for simplifying sine of x plus h. Now we need one more kind of ingredient to be able to finish what the derivative of sine of x comes out to, so what f prime of x is. And there's two trigonometric limits, which are good to know. The limit as x approaches 0 for sine of x divided by x, and then the limit as x approaches 0 for cosine of x minus 1 divided by x. Now, if you take all these things together, the sum of angles formula, simplifying sine of x plus h, combine it with the trigonometric limits, gets a little complicated. Some of you might be interested in carrying that out in detail, but I'll tell you the end result of going through all that. The limit definition for the derivative of sine of x, it simplifies to cosine of x. So we apply the limit definition, we use a kind of forgotten trig identity, sum of angles formulas, and we use a trigonometric limit. The end result, the derivative of sine, is cosine. And this result, as we mentioned, is only valid if x is in radians. If x is in degrees, this is no longer true. So we'll be sticking to radians to say that the derivative of sine is cosine. All right, now there is one trig function's derivative. The derivative of sine is cosine. 5 more to go. Now we're not actually going to go through what we just did here with the limit definition in detail, but this at least is our foundation. So at least you can see, hopefully, that we're not just making this up. Everything we're learning is built on a solid foundation. All right, so let's get to the next part. What I have here is kind of a peculiar arrangement for the 6 trig functions. This will make sense in a few more minutes. So there's 6 in total. I'm arranging them with sine, tangent, and secant in the left column for their derivatives, and then cosine, cotangent, and cosecant on the right. This will make sense in a little bit. We're just arranging them. What we know currently, the derivative of sine is cosine. All right, now if you repeat the argument that we just did using the limit definition, the sum of angles formulas for cosine, and those trigonometric limits, you'll get a similar result for the derivative of cosine, but it's slightly different. It comes out to negative sine of x. So leave that to you if you're curious about the details, but now we know 2 out of all 6 trig functions and their derivatives. Derivative of sine is cosine, the derivative of cosine is negative sine. Okay. Now, I want to give you a chance to come up with one of the others, the other four here. And we're going to make this example 1. Make sure you at least pause to copy down these trig identities. And we're just going to apply the quotient rule to tangent of x. We're going to think of tangent as its identity sine of x divided by cosine of x. That will allow us to use the quotient rule and the derivatives that we now currently know, the derivatives of sine and cosine. When you're ready, we'll get right to example 1. All right. Now, I'd like to give you an attempt at this. Once we know the derivatives of sine and cosine, that is it. We kind of build off of that to get the other 4 trig functions derivatives like we have here. So let me just give you a hint. I'd like you to try this. We need to know the derivative of sine is cosine, and the derivative of cosine is negative sine. The other thing we're going to need is the identity tangent of x equals sine of x divided by cosine of x. That allows us to apply the quotient rule, since we can now view tangent as the quotient or fraction sine divided by cosine. So pause, give yourself an attempt. Some of you might be able to see how the pieces are coming together. Some of you might feel a little overwhelmed. Trig functions are notoriously difficult and often forgotten by the time students reach Calc 1. So don't feel like you're behind if you can't put the pieces together. But pause, give yourself about a minute, and see if you can apply the quotient rule. All right, now, hopefully you tried this. It's okay if you didn't and just feel stuck. So we're going to go through this in steps. First, let's just use proper notation. The wording, find the derivative of tangent of x, we can write this as, in Leibniz notation or differential notation, the derivative with respect to x, and then of, within brackets, tangent of x. First thing we're going to do is replace tangent using the identity tangent of x equals sine of x divided by cosine of x. And here, I'd like you to think of this as a straightforward application of the quotient rule. The only new part is now we are using new functions, sine and cosine, and their derivatives, which we just learned. So if we apply divide and conquer, the numerator f is sine of x, the denominator g is cosine of x, and the respective derivatives for f prime would be cosine of x and g prime negative sine of x. That is pretty much it. The rest of it is just combining those 4 pieces with the quotient rule. If you felt stuck before, see if you can complete it here. Combine the pieces, giving you the derivative of tangent of x. We'll check in about a minute. All right, so let's go through this. We have all the pieces there. So we divided. Now we can conquer the problem, combine those 4 pieces back using the quotient rule. All right, just be careful with your signs, positive or negative. We've very easy to confuse students, as I've noticed in class. When I say sine, I could mean the sine function, or I could mean a positive or negative sign. So just be careful with your minuses there. We have in the quotient rule the subtraction between f prime g and f g prime. But notice there is itself also another negative or minus in g prime. So just be careful. We can simplify that. Notice the negatives, when we multiply them, will cancel to a positive. And we're left with our numerator, cosine squared plus sine squared. And then in the denominator, cosine squared. That's g squared. All right, this looks at least like an answer. It is the derivative of tangent, but due to some other trigonometric identities, this will simplify considerably. Now, I'm trying to be vague. With squared trig functions, we usually want to think of possibly applying a Pythagorean identity. And this one will pop up a lot throughout questions we're covering within the lecture and then questions within the homework. So we're going to use the basic one here. Cosine squared of x plus sine squared of x equals 1. What that allows us to do is simplify the entire numerator. It just becomes 1. And we can now write in a simplified form, the derivative of tangent is 1 divided by cosine squared. Now, if you're really on top of your stuff, that can even be rewritten. 1 divided by cosine, the reciprocal of cosine, is secant. So 1 divided by cosine squared, well, we can think of that as being secant squared. And that is the standard answer. We're going to say that the derivative of tangent is secant squared of x. So the derivative of tangent of x is secant squared of x. All right, and that's how we start combining the quotient rule with our two fundamental trig functions, sine and cosine, and their derivatives. At this point, we now know 3 out of the 6 trig functions derivatives. Now, we're not going to go through all the other 3, but they follow very similarly to what we did here in example 1. Cotangent would just be flipped. Cotangent of x is cosine of x divided by sine of x. Secant of x, as we used here, is 1 divided by cosine. And cosecant of x is 1 divided by sine of x. So just apply the quotient rule, and you can prove the other trig functions derivatives. When you're ready, we'll just move on to summarize and then get to a bunch of examples. All right, let's go ahead and give the summary of all 6 trig functions and their derivatives. All right, now I have here only 3 out of the 6. And we're going to leave the other 3 blank temporarily. All right, there's going to be a particular pattern I want you to notice between the way these 2 columns are arranged. So we have sine, tangent, and secant in the left column, cosine, cotangent, and cosecant on the right. All right. Here's the rest of them, the complete table. They all follow by applying an appropriate identity. For instance, secant, you can think of secant as 1 divided by cosine. And then we apply the quotient rule. All right, you definitely want to memorize these, especially if you're continuing beyond Calculus 1 through the calculus sequence. But I want you to notice in the right column, the derivatives of cosine, the derivative of cotangent, and the derivative of cosecant. Any of those trig functions with a co in the name, notice all of their derivatives have a negative sign in them. And that's a way that you can kind of help speed up memorizing, cutting down, thinking this is, instead of being 6 separate derivatives to memorize, it's 3 with minor modifications. All right, definitely pause, copy these down. We're going to be referring to them through the next few examples. When you're ready, we'll advance to a first simple example, example 1. All right, when you're ready, let's get to example 1. Oh, sorry, this is example 2. We already did example 1. All right, the question here, rather simple. Find the derivative of y equals x squared times cosine of x. Now think of what rules you might apply to this. Now we're going to start combining what we're currently learning, the 6 trig functions and their derivatives, with previous rules. Power rule, product rule, quotient rule, just all going to be combined together. So pause the video, give yourself an attempt at this one, example 2. And it's kind of a straightforward problem applying the product rule. We'll check in maybe 1 to 2 minutes. All right, we're going to go through this applying divide and conquer. So we kind of already have this written as a product. So we'll think of x squared as being the f of x, and then cosine of x as the g of x. Calculate the respective derivatives. The only new part is in differentiating g of x. We just learned, and it might not have sunk in yet, but the derivative of cosine is negative sine. So all the work is done. We can just now combine these 4 pieces together using the product rule. And we can simplify that slightly, just getting rid of the parentheses and changing the plus to a minus there. And we get as our derivative, y prime, 2x times cosine of x minus x squared sine of x. Hopefully, divide and conquer, you've been using it in examples going through the homework. Hopefully it's kind of sinking in. You kind of have hopefully an easier time going through applying the product rule kind of at this point in the course. So that's really it for example 2. Straightforward application of the product rule. The only new part is we have to know the derivative of cosine of x, which is negative sine of x. All right, that's going to conclude part 1. When we start part 2 right after this, we'll be getting through a lot of examples dealing with other questions that we saw earlier, and then the other trig functions and their derivatives that we haven't used here. We'll see that within part 2.